right, welcome to the start of section 6.3. Here we're going to be finding probabilities, not using the empirical rule, but using our calculators so that we're going to get not an approximation, but a more exact probability. So remember, as we do this, this is going to be for continuous variables. Okay, back in chapter 5, when we used binomial PDF and binomial CDF, that's where we were talking about discrete variables, things that could only take on whole number values. But remember now, in chapter 6, we're now looking at continuous variables, so things that can be divided up infinitely and infinitely smaller. Okay, so we are going to get some calculator instructions as we go through this one, so keep that in mind. I'm going to give you instructions as always for the TI 83 and 84. Those of you without those calculators, I trust you'll be able to find the same information through Googling as you normally have. Okay. All right. So let's say we have a brand of light bulb, and the lifespan of a light bulb is normally distributed with a population mean, and we're not going to continue to say that most of the time. When it says with a mean, assume that means population, of 1,550 hours and a standard deviation of 57 hours. So again, just to kind of hit that notation that we're going to use, that means our variable lifetime of the light bulb is normally distributed with a mean of 1,550 and a standard deviation of 57. Okay, so find the probability a randomly selected light bulb will last between 1,525 and 1,625 hours. Draw and shade a normal curve. So I'm not going to spend a ton of time being super precise about this normal curve, but again, just to kind of get a picture of what's going on here. Okay, so our mean of 1,550 is right there in the middle. Okay, working our way on up, so 1,550 plus 57, going one standard deviation to the right of the mean, would put us at 1,607 hours. Going another would put us at 1,664. I'm going to stop right there, going to the right. And again, that is because we're being asked to find 1,525 to 1,625. I've already got that range in there. And then when I go one standard deviation below the mean, I end up at 1,493 hours. And again, 1,525 is in that range. So let's say, oops, sorry about that. Let's say we're right about here, 1,525 to about 1,625, right about here. So the region that we are looking to find is this part right in here. Okay, so remember, that is the area, which is also the probability. Those are the same thing. Area equals probability. So what we're asked to find is that the probability that the span of our light bulb is between 1,525 hours and 1,625 hours. Okay, so what we're going to do on our calculator is use a function called normal CDF. Now, just for a second here, I'm going to start writing in the box down below. Okay, so we want to find the command normal CDF. A lot of you found this whenever you looked for binomial CDF and binomial PDF. You accidentally had picked the wrong one. So on your TI 83 and 84, again, you're going to hit the second button. Then you're going to hit VARS, again, just down and to the left of your down arrow key. And then number 2 on most calculators is where you will find normal CDF. Okay, just a note, we will never, ever, ever, ever in this class use the normal PDF function. So do not choose that one. Okay, please be sure you're at normal CDF. All right. Then those of you with prompts, you're going to see something that says like lower, upper, mu, and sigma. Okay, for those of you without the prompts, so the ones of you that have to type in the numbers like in the parentheses on your own with commas in between, again, I'm going to write these instructions for you. Okay, so you will have normal CDF pop up on your calculator. Then what you're going to write down is the lower boundary, the upper boundary, the mean, and the standard deviation all separated with commas. Again, those of you with prompts, no problem. We've got it all spelled out. Okay, so I'm going to go back up to the problem that we were working on here just for a minute. Okay, so in this particular situation, and again, I'm going to write this out for those of you with the no prompt calculator, you would want normal CDF. Our minimum, our lower boundary is the 1,525 hours. Our upper boundary is the 1,625 hours. The mean is 1,550 taken from the problem, and the standard deviation is 57. Okay, then when you hit equal, and we are always going to report these to 4 decimal places, again, check in my open math, we should get an area or a probability of 0.5754. Okay, again, to interpret that, that would mean about 57.54% of all of this type of light bulb would last between 1,525 and 1,625 hours. Okay, now there is a little note here that says, what if there isn't a minimum or a maximum value? Okay, what if it just says like more than this many hours, and then there's no minimum or maximum? Okay, so if there is no minimum, this is what you would use. Okay, for the minimum, either use like negative like 100,000 at least. Okay, actually go for 1,000,000, even better, because there could still be some area there. Or what you can type is negative 1e99. That's like typing negative 1 times 10 to the 99th power on your calculator. That e is found on your calculator by doing second and then hitting the comma button. Right above that is a capital EE, and that is what types the E on your calculator, and then you would do 99. Okay, if there is no maximum, we're going to do the same thing in the other way. You can either type in 1,000,000. Again, you're just trying to get so far away from the center of the curve that really the area under the curve at that point is 0. And then for a maximum, use positive 1 times 10 to the 99th power, or that 1e99. All right, so having said that, I would like you to pause the video and try question B. All right, so hopefully you drew your normal curve. Again, I'm not putting in all of the numbers, 3 standard deviations above and below. If I go 1 standard deviation below at 1493, I can get my 1,500 hours in for a quick picture. So again, we're going all the way down to the left. There is no minimum on that. So as you use your normal CDF function, again, that minimum value, I'm going to use the negative 1e99. Again, if you prefer to type in negative 1,000,000, have at it. For me, it's faster to write negative 1e99, so that's why I'm going to do that. Maximum in this case, or upper boundary, would be that 1,500 hours. Again, the same mean and standard deviation as before. And whenever you hit equals, you should get 0.1902. Okay, so notice in this question it said find the proportion of these light bulbs. That is really the same as finding a probability. I'm going to keep changing up the phrasing as we go through because lots of times you'll see all these different wordings, and so I want you to be familiar with them and know they all mean the same thing.